Howdy, y'all. Welcome back to Moltar Aviation. So this is a part 4 series talking about the Earth's atmosphere and heat imbalances. And so this is the second video in that series. In this video, I'm going to be talking about heat imbalances. So I'm Dr. Andy Moltar. I'm a flight instructor, a CFI IIMEI. I'm a former corporate pilot, and I'm a professor of aviation. And aviation weather is one of the classes I've taught. So hey, you're getting this information for free, so feel free to subscribe so you can keep on learning more about aviation weather. All right, so proper heating and cooling of the Earth's surface and the atmosphere depend on sensible heating and latent heat. And so I know we talked about a little bit about latent heat previously, but sensible heating, that involves both conduction and convection of the air. And it occurs due to differences in air density, and that's because warm air is less dense than cool air. And so here's an example of conduction here on the left. And so conduction, and when we talk about conduction and convection, go back if you haven't seen it already. Part 2 talks about heat and temperature in the aviation weather video playlist that I have, and I'll link that playlist in the description below. But when we have conduction, so the surface, during the day, it's going to receive a lot of solar radiation from the sun, and so it's receiving a lot of that heat, and then any cool air that touches that ground, well, that heat's going to, through conduction, is going to heat that air. And I'll go ahead and make my pointer a laser pointer. So the hot surface is going to heat up that cool air that's touching it, and it's going to create a thermal. And so that thermal, that hot air, it's going to be lighter than the cool air. And so that warmer air is going to want to rise. And then eventually it just becomes a thermal open air. And so here on the right, now we have convection. So that's when heat is transferred through the swirling air. And so, in fact, this is how gliders are able to stay up in the air for so long, because they'll kind of glide around for a little bit. And then once they catch a thermal, remember, hot air is going to be rising air. And so they'll do like a steep turn and just kind of climb in that thermal until the thermal stops. And then they just start gliding somewhere else until they find another thermal. And they'll just keep doing steep turns until they get to the top of that thermal. In fact, they know where a thermal is if they can see like a cumulus cloud somewhere in the sky. So they'll just kind of glide toward there and then just ride that thermal up. All right, and then if you haven't seen it already, I recommend you go back to my, I believe it's the 3C video in the aviation weather series. That's where I talk about the change of phase of water vapor and the latent heat that results from that. And so as the Earth's surface absorbs radiation, some of that heat is produced, some of the heat produced is used to evaporate water from bodies of water, soil, and vegetation. And so as the water evaporates, it absorbs heat, and then heat is released into the atmosphere when that water vapor condenses into a cloud. And so, we see here on this latent heat graph or picture. So the red represents the absorption of heat, and then the blue represents the release of heat into the environment. So when you have that liquid that evaporates into a water vapor, heat is absorbed. So that's why it kind of feels nice and cool near a lake versus, out on a hot ranch or something. But then when that water vapor condenses back into a liquid, then heat is released back into the air. All right, well, that's it for this video. In the next video, I'm going to be talking about heat imbalances with latitude. If you would go and subscribe, that way you get notified when that video comes out. All right, you take care. Bye-bye.